All right, so I want to walk you through the way that we build agents, agents of Vercel. I guess we can past tense now. I'm going to share some cool libraries, some cool dev tools, and hopefully this will help you build and scale your own agents. And so over the next 15 minutes, we are going to see how internally we build unique agents from ground up. So I am Hayden, the logos that make me feel good about myself. I should say, obviously, when Resend asked me to do this talk a week ago, I was a DX engineer at Vercel. This week, I just started at OpenAI. So this isn't propaganda, even though it's an extremely Vercel-pilled talk. It's stuff that I actually think is going to help you if you are building agents, and seeing as you're sitting in a room in YC in 2026. If you're not going to make it. All right, so for every agent and framework that we launch publicly at Vercel, we probably have another 10 internally. Some of them are going to come out soon. Some of them are for our eyes only, but for every agent, we use a very, very similar approach. We build the agent, we figure out the hard parts, and then we extract that into a library and then democratize it and open source it so that other teams in the company can use it, but also all of you can use it. And then when that part is done, we obviously just try to double down and make it better and faster and more powerful with more tooling. So this is, give or take a few boxes, what a typical agent looks like in Vercel. And they're all based on primitives that you can use in your own projects. So yeah, I want to show you as many primitives as I can in 15 minutes before they kick me off the stage. So this is going to be a bit of a speed run, but let's get into it. So let's start off with the agent core. This is going to be the fundamental toolkit that we're going to use to help build an AI-powered application, or more likely an agent. And this core agent has to do a few basic things. We've got to connect our model to our UI, and we need to generate or stream LLM content. And it effectively just needs to be an engine or a harness for the rest of this. And you can probably guess what we use for this. It is Mastra. No, I'm kidding. It's the AI SDK. I'm allowed to say that stuff now. It's fine. So if you haven't used the AI SDK, it's very similar to, say, the amazing OpenAI Responses API, or the Claude SDK. But because it needs to work with every model, the AI SDK team have done an extremely good job in building out this intelligent, very flexible harness with a lot of tooling behind it. And you can use it to mold your agent into pretty much whatever you want. So this is one that we've set up using the tool loop agent class. And all we have to give it is a model, which I'll talk about in a bit, instructions, which is our equivalent of a system prompt. And you can also add multiple stop when clauses, which is really interesting. So this is useful because the tool loop agent, which is aptly named, runs tools in a loop. So you can define when you want to terminate it. So for example, I want to stop it after it's done 20 steps, or I want to stop it when it's hit 500,000 tokens. And so one of my favorite things is that you can also define what is called a structured output, which means if you run the agent and at the very end you actually want JSON that you can save into your database or send on to another tool, you can do that. It's very good for classification work or turning unstructured data into structured data. So we've now got this standalone agent object that we can import into other files, and then we can just run agent.generate or agent.stream and pass in a prompt, which is easy. Okay, so we've got the agent that can run on, say, a Next.js route handler. How do we stream this into the UI? Well, the AI SDK has us covered there as well. There's a React hook that you can use to send and receive from that route handler and stream it into the UI in real time. So that is effectively the agent core sorted. We can now generate and stream text and JSON with the constraints that we need, but we have pretty much made a ChatGPT wrapper, which describes half the startups in this city. We now need to make it useful by adding specific tooling. So let's say the ability to hit up our database or to hit up an external API. And so for that, we need agent tools. So we can start by defining a bunch of tools. Each tool is simply just, in the form of the AI SDK, it's just a description, an input, and an execution. So here we're going to build two. We've got the get user tool, which gets the user info given the user ID, and we're just going to do a database lookup here with this incredibly good SQL statement that I've written. There's absolutely no problems there. There's also the get current stonks tool, which gets the current stock ticket data from the Alpha Vantage. Yes. And so it's basically just a glorified fetch call. And we don't actually need to worry about formatting the response. We can just pass the response directly back into the agent. It'll figure out what to do with it. So now we just need to attach those tools to our agent. So the agent harness that we put together before, you can literally just pass the tools in, and then we can execute a prompt like, hey, can you get user XYZ's favorite stonks and tell me how they're doing? And that's going to run a tool loop. So it's going to do some upfront reasoning, depending on your model. Fire the get user tool, get that user data, then get the stock tickers off that, pass it through the get stonks func tool, and then return that back into the stream. And then it'll figure out how do I tell the user what I've just discovered. So now we have successfully made it past ChatGPT wrapper stage, and we have an agent specifically designed for a given task. Now we need to choose a model for it. So there are hundreds, maybe thousands of models out there at this point, I'm not sure. And they're all from different labs. And not only that, certain models actually are on different providers as well. So like I think Moonshot, Unbreakable, Kimi K2, that is on, I think, like Amazon Bedrock and Fireworks and Together and a few other ones. So we need some sort of backend to serve the models to our agent core that is simple, preferably, but also very reliable. So it's like if one model or one provider goes down, we can just fall back onto another one. And so for this, we use our magical AI Gateway. So it is super cool. It's actually one of my favorite things, but it's Vercel's flavor of, like, say, OpenRouter. If you've used that, you can pick from like thousands of models, and then it just sorts out the API keys and the billing and all that sort of stuff for you behind the scenes, which is really nice. All you actually need is the string. That's the only thing that you actually need. But if you want, you can go through and you can tweak all the knobs and stuff like that. So you can define things like what order the providers run in. So it's like run Bedrock first, and then if that fails, go to runtogether.ai, which can help optimize for cost or latency. And then you've got only. So if you have some like compliance internally, so it's like we can only run on these specific providers, you can do that. You can fiddle with caching. No idea what that does. And you can also specify fallback models, which is incredibly handy if you're running Claude Opus and it's down 24/7. I wrote that when I was back at Vercel, by the way, so it's not considered competitive. All right, so now we have a very reliable model backend. Next up, we need to build a UI that doesn't suck. That's the benchmark. This is actually where my work at Vercel comes in. And for this part, we are going to use AI elements and Streamdown. So when you're building a chat interface, there's like a million things that you need to think about nowadays. On this little diagram thing that I put together, you've got messages, reasoning, suggestions, and the prompt input at the bottom. But then, as the chat evolves, I have to read this list. Attachments, chain of thought, checkpoints, confirmations, context, inline citations, model selectors, plans, queues, shimmering, sources, tasks, and tools. So for this, one of my pet projects at Vercel was putting together AI elements. It's like a custom ShadCN registry with like 50 or something components for all sorts of AI in spaces, not just chat, but for like voice agents, coding IDEs, workflows, all that sort of stuff. So you can just install them into your code base by running a single terminal command. And because it's ShadCN UI, if you're using that in your code base already, it just immediately looks like the rest of your app. So while I was building AI elements, I found the most complicated component to get right was the message component. Think of everything that a modern LLM returns to you, right? It's like rich text, code blocks, images, mathematics, mermaid diagrams. There's a bunch of stuff, right, that just happens inside as raw Markdown that just comes back to you. So I ended up building another library underneath the message component to make Markdown great again. That library is called Streamdown, and it was it's my second project at Vercel. And it's basically a fully loaded Markdown renderer. So if you've used React Markdown, I hope, it's a replacement for that specifically designed and optimized for streaming. But as we were building out Streamdown, I realized that streaming Markdown introduces this like brand new set of problems for the end user experience. So like think about streaming, when you stream back Markdown into the browser, it chunks it, right, into like these little pieces of text. So if you're halfway through a Markdown tag or a code fence or whatever it is, it's going to literally appear like this before it then cycles and then looks proper in front of the user. So we needed some way of fixing the Markdown as the LLM was streaming it into the browser. So to fix that issue, we created another library called Remend for, come back. Okay, for self-healing Markdown, which is a really fancy way of saying it's a bunch of regexes that tries to fix the incomplete Markdown as it's streaming in so that the user always sees complete and beautiful Markdown. It's pretty cool stuff. All right, that is enough about the web. I want to talk about the one at the top left now. Most modern AI agents are more integrated into your existing tools like Linear and Slack and Discord and Teams and all that sort of stuff. So for this one, we released the newly minted Chat SDK. I don't know if you've seen this yet. That was my last project at Vercel. So the Chat SDK is a unified interface or message-based system. So we can write all of our agent logic once, like I've just shown you with the tool loop agent, and then we can hook it up to this thing and then pass in adapters like Slack, Discord, Teams, Resend as an adapter, vendor official. And so in this example, I just quickly put together an adapter with a Slack bot and a Redis KV cache for persistence. And then in our route handler, we can just tell the bot what to do when it's mentioned on Slack or when somebody reacts to one of its messages or when it gets a follow-up message, which is super cool. All right, I'm gonna pick up a bit of speed now. So our agent is now useful and it can be used across web and native interfaces, pretty crazy. But it's still basically a ChatGPT wrapper with some tooling. We need a way of loading highly specific knowledge into the context window when it receives a relevant task. And you probably guessed it, for that, we're gonna use skills. So hopefully you're a little bit familiar with skills after the very impressive presentation that has mogged mine. But anyway, Vercel has a thing called skills.sh, where you can effectively find collections of Markdown files and then load them into your local agents, like Codex. And I gotta do it, man. I'm paid by the hour. I find this incredibly useful with services like Resend or like stack tools like Convex or Next.js, because you can get the latest, most up-to-date documentation and guides on how to properly implement these things and then load them directly into your agent's context window. But what is less well known is that you can actually write a simple tool, an agent tool for the tool loop agent that dynamically loads skills when they're needed. So let's say that you're building a coding agent for the web. You can just load it up with skills for React best practices, Next.js, Convex, Sentry, Resend, whatever, and then it's pretty much a genius at whatever you throw at it. Great way of building a code review bot. Okay, so that's skills sorted. We've now built a handful of these tools, but let's be honest, it's JavaScript. Something is bound to fail with a blip of a network issue or something like that, or a TypeScript issue. But so what we need is a way of running this agent and its tools in a more durable way. And for that, we have everybody's favorite SDK, workflows. So let's say our new agent handles user onboarding, right? It runs a function called welcome that gets the current user and then sends them an email using the best email SDK of all time. Thank you. But anyway, this is a, please come back. Please. All right, cool. I thought they finally kicked me off. This is a set of functions that is simple, but not particularly durable. So if the SQL statement, or God forbid, the resend network request fails intermittently just because of a blip in the network stack, the entire thing is going to fail. And so realistically, we can retry, and there's a lot of different ways of doing this, right? You can do a basic JavaScript function to retry it with a fall off or a ticker or something like that. You could use effect, which Reese keeps telling me to do. But the way that we do it is literally just to add some strings to the function. So we add the use step directive to each of the steps and the use workflow directives to the main function, and it is automatically durable. It will retry if there's any network errors, and only the steps that failed will rerun with their appropriate context, which is pretty amazing stuff. Okay, all right, we're almost there, don't worry. Now, all of our tools are durable, but we have another issue. If you are building something like a coding agent, so it has all these amazing tools, and it has it runs in a durable workflow fashion, you effectively need to clone GitHub repos, right? And you need to go to work on them if you're reviewing the code or fixing bugs or looking for leaked environment variables, which I may have done. But we can't just clone the GitHub repo into memory, because in the route handler, because if we did, I mean, Vercel would be very upset, and it would be super insecure if we try to go to work on it. So to solve stuff like this, we can spin up an isolated environment with Sandbox. So we can use Sandbox to spin up an ephemeral Linux environment super quickly and then just load the GitHub repo into it. And then you can do whatever you need. You can fetch and check out and diff and run reviews and run code and search for stuff and find those environment variables that I leaked. And you can do it without worrying about insecure code, because as soon as this sandbox finishes, it'll just self-destruct. So it's very handy. Okay, last one, I promise, last one. Bonus round, because this is a DevTools meetup. Is anyone here familiar with linter and formatter tools? So like ESLint, Prettier, Biome, OXLint, OXFormat. I think those are the top 5, right? All right, I know some of you know what I'm gonna say. All right, you might like this yet. So Ultracite is this library that I maintain outside of Vercel, which is a super strict production-grade preset for all of the linters and formatters. So the goal is to help you and your team and your agents get into the same coding style with like absolutely zero config and without needing to like manage thousands of lines of tooling and stuff like that. So for example, this is our biome config prior to using Ultracite at Vercel. I'm not even joking, thousands of lines of config to determine which rules are on, which rules are off, which ones conflict with each other, which ones are too slow because of the scanner, which ones are bad, all that sort of stuff. I managed to migrate a couple of the projects so that that is the entire biome JSON. So effectively, you just extend Ultracite's, in this case it's biome, but you can do it for whatever. You just extend the presets with the stack that you're using. So core, next, react, vtest, you can do, I don't know, whatever your stack is, Astro, Spelt, all the, whatever the cool kids are doing nowadays. Anyway, that's all I have time for. You've been great. I've been Hayden. If you do want to chat or complain about my stuff, you can hit me up on X with my super creative username, and I'll see you next time.